Alright, let's see how the p-value behaves when we try repeated hypothesis testing. So here I've got a value, we've got the true mu value for a population and the true sigma value, and then I'm simulating a normal random variable with the mean and the sigma value from here, doing it again there, and again there, and again there. My null value is 0. I set my alpha to 0.05 as usual. I take the average of those 4 data points, I take the standard deviation of those 4 data points, I compute the standard error, s over square root of n, I compute my t-test statistic, and I compute my p-value, and then I say if the p-value is less than the alpha value, then we reject, and we note that with a 1, otherwise we fail to reject, and note that with a 0. So our first question, do we actually achieve an overall alpha of 0.05 when the null is true? Well, here the true population mean is 0, although that's not true for any one particular sample. How many samples do we have here? 200 samples, each of size 4. So the true population mean is 0 and my null value is 0, so the null hypothesis is true. And we want to know what percent of the time do we reject the null. Well, every now and then I see a 1. What percent of the time is that? We can just take the average of the binary data, and that tells us what percent of the time it's a 1. Did we get 5% here, like our target 5% for alpha? Well, no, we didn't, but we can get new random numbers by pressing F9 and see how this number behaves when we try more repeated samples, each of size 4. Would you say that's hovering around 5%, that it's kind of plausibly 5%? I think that's good enough. Yeah, close enough to 5.